Write an expression for the autoionization of water. So you would first write water in water because it ionizes with water, and it would produce a hydronium ion and an OH ion. Question 6. Water ionization constant is the following. At 25 degrees Celsius, calculate the concentration of the hydrogen ion in 0.01 moles of HCl solution, assuming that HCl fully ionizes. First of all, with such questions, you have to write the chemical equation. So here is a chemical equation. HCl, which is in liquid form, would ionize with water. It would produce a hydronium ion and a Cl minus anion. Now, because we know it fully ionizes, we know that all of the HCl here would ionize to produce hydronium ions. Again, we would balance the equation, and when we have the correct coefficients, in this case all of the coefficients are 1, we would write down the concentrations. So the concentration of the HCl is 0.01. Since it's a 1-to-1 ratio, the concentration of the hydronium ions are going to be 0.01. Now, to simplify this, what I would do is first think of the HCl as a molecule. So let's say we have 2 HCl molecules, and during ionization what happens is that this HCl molecule would turn into a HCl ion and a Cl ion. Because it fully ionizes, all of the HCl molecules would ionize to H and Cl. So how many molecules of HCl do we have here? 2. And how many molecules of H do we have here? 2. That is exactly what is happening here, but we're taking this into a simpler step. Moving to part B. Part B requires you to find the concentration of the hydroxide ions in 0.01 moles of HCl solution. Now, for this part, you would need to know your answer from the other part, and the answer was 0.001 moles. So first you would use your ion product constant. So this is the formula. K, ion product constant is Kw over the hydronium ion concentration. From the earlier question, we know that the hydronium ion concentration is 0.01 moles. So you would get 1 times 10 to the power of minus 14 over 0.001 moles. And again, you write the units, so the units cross out to give you 1 times 10 to the power of minus 11 moles. And that's your answer. Moving on to question 7. Question 7 is a multiple choice question. It asks, drain cleaner and ion cleaner are very corrosive substances. What is the main compound present in them? We know that drain and ion cleaners are made of bases. So let's see the options. We have option A, hydrochloric acid, option B, sulfuric acid, option C, sodium hydroxide, and option D, vinegar. Option A is hydrochloric acid, which is an acid, and ion and drain cleaners do not contain acids, they contain bases. Again, with option B is sulfuric acid. Again, an acid, not a base. Option D is vinegar. Vinegar is ascorbic acetic acid, so it is not option D. We're left with option C, which is sodium hydroxide, and it is a base. Drain and ion cleaners contain bases. Sodium hydroxide is a very strong base. So the answer is option C, sodium hydroxide. Going to question 8 now, which is again a multiple choice question. Why is ascorbic acid sometimes added to fruit juice? Is it to neutralize any base present, or to preserve the juice, to increase vitamin content, or to improve appearance? We know that ascorbic acid is commonly known as vitamin C. So is it to neutralize any base present? There is no base present in fruit juices. Is it to preserve the juice? Ascorbic acid is not added to juices as a preservative. Option D, to improve the appearance. It is not to improve the appearance, but it is to increase the vitamin content because it has vitamin C. Ascorbic acid is commonly known as vitamin C, and it is added to fruit juices to increase the vitamin content. Therefore, the answer is question C, part C. So that wraps up the lesson for acidity and pH. And we talked about how acids and bases react in water and also some uses of acids and bases.